Okay, 512, factoring special products. Ultimately, if you look at 511 and 512 kind of side by side, you'll realize there's not a ton of difference. Polynomials on both sides. Probably one of the differences in 512 is in 511, everything, of course, if you remember here, when you set up your two binomials, that would be your answer, you would always have an x and an x, and then whether it's plus or minus and what numbers go in there, you gotta kind of use the process there, figure out what times what equals that, and then that same two digits need to add up to that. I can see this one here would be 5 and 4, positive 5. Positive 4 is positive 20, positive 5 plus positive 4 is positive 9. So for number 12, that's what we would have. These are very kind of similar, I guess, but we're going to be looking back and talking about, again, you'll notice some of these are a little bit bigger, and I'll show you how that's going to work here. But we went through 3 different type of formats back in lesson 5 dash. Was it here? 5-8. Yeah, this was our lesson here. We went through. And so there were 3 different types. 512. We'll just kind of go through those there. Okay. So first we had this form here, where we would just, I'll give you an example here in just a minute. Then we have the other one here. Give you some examples of these in just a minute. So we use these here to factor perfect square trinomials. Here, factor perfect square trinomials. I'm going to explain what that is here in just a second. So I'm going to write one out here. Let's go with this one. X squared plus 10x plus 25. So for this to work here, this is what needs to happen. 2 things need to happen. First, the first and third terms need to be perfect squares. You remember what a perfect square is? So perfect squares are 1, 4, 9, 16, 25, 36, 49. See what I'm doing here? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. 1, 4, 9, 16, 25, 36, 49, 64, 81. On and on it go. Those are all perfect squares. They have a clean square root. So again, 1, 4, 9, 16, 25, 36, 49, on and on it goes. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. So for this to work here, it must be a perfect square for this strategy to work. And if you look a little closer here at some of these problems here, you'll probably realize all these first and third terms are indeed perfect squares all over the place here. Okay. Second, so this is the first thing. The first and third term have to be perfect squares. In this case, they are. Finally, the other thing that needs to be true is the middle term. The middle term is either, how should I do it? Positive 2 or negative 2 times the product of the square root of the first term and the third term. So it's kind of a mouthful there, but I'll show you how this works. The middle term is either double times 2, positive 2, or times negative 2, the product of the square root of the first term and the third term. Again, it sounds like a lot here, but so this will meet the perfect square trinomial criteria, because what happens here is the first and third term are perfect squares. This is basically 1, the square root of 1 is 1, and the square root of 25 is 5. So yes, meets the first criteria. The middle term is either, and again, if you see this here, then it's going to be positive 2, and if it's a subtract, it's going to be a minus 2. These first and third terms are always going to be positive, though. Always. Because a negative times a negative makes a positive. So we see it's positive. That's times positive 2 times what? The product of the square root of the first term. So what's the square root of 1? 1. And then multiply that times the square root of the third term. What's the square root of 25? 5. And then I multiply by either positive 2 or negative 2. I'm going to multiply by positive 2. 1 times 5 times 2. There it is right there. There's my 10. So the square root of the first term, the square root of the third term, 1 and 5, multiplied by either positive 2 or negative 2. In this case, positive 2 because of positive. So what do I do with all that then here? Well, what I can do here is, again, this would be that answer. This is because it meets the criteria for my perfect square product. I can write it this way too. Doesn't really matter. I can either you just write it once and squared, or I could write it as 2. It doesn't matter. Both of these are the same thing here. But basically this worked in here because, again, it had to be a perfect square, which it was. And then double the square roots, yep. And then it fell into this format. Either I can represent it this way or this way.
Good morning.
Let's look at number 3. Let's see how that one works for you. Z squared plus 22z plus 121. And we're going to walk through and use our method here. So first thing I should always be on the lookout for is perfect square trinomials. And this one does meet the criteria. At least the first and third step. The first and third terms do. You never really can tell about the middle one until you're done with it. But again, basically I got the square root of 1 over here. And the square root of 121 over here. So what's the square root of 1? What's the square root of 121? 11. And then I would multiply by a positive 2. So 1 times 11, there's my 22 right there. So that means my answer is z plus 11, or just z plus 11 squared. Because again, I take my first term, there it is there, that's my z term. That's my 11 term, and then doubling it, because I'm basically just multiplying everything times itself, gives me my middle term there. Try number 5. So only real difference here is this one's a subtract. Over here, it's the square root of 1, square root of 100. Square root of 1 is 1, square root of 100 is 10. And then here in the middle, I see I got a subtract sign, so that means I'm multiplying by -2. Positive 1 times -2 times positive 10 does give me that -20. So what did I do? X minus 10 times x minus 10. The square, the double. Let's look at number 9. So number 9, I'm not going to call it S, I'm going to call it N, is different than any of the ones we've had to date. And it's different in the sense that we now have a value over here. Everything, at least we've had to this moment here, there's just been a value of 1 in that spot there. If you go back at the homework we checked, they all had a value of 1. So this is going to set up our bridge to the final chapter where we're going to have a different number besides 1 in this spot. But for now, we want to, again, consider our perfect square process. So what's the square root of 4? 2. And then what's the square root of 49? 7. And then I got to subtract, which means I multiply by -2. And if this all multiplies up to -28, then I have a perfect square trinomial. 2 times -2 is -4. -4 times 7 is -28. Meets the criteria here. So what did I have? Well, there was my first term, there was my second. So to get the 4n squared, I multiplied 2n times 2n. Because remember, we're in the perfect square format here. I subtracted, and what did I subtract? 7 squared. That would be my answer right there. Or this way. And again, if I go back and FOIL it, 2n times 2n, there's my 4n squared. 2n times -7, minus 14n, minus 14n again, -7 times -7, positive 49. These will combine together. And there we are, right back at the start. 4n squared minus 28n plus 49. Square root, multiply by either positive or -2. And then whatever you have here, plus your variable, that's your first term. And then whatever you have here, that's your last term. Your plus or minus sign is dictated by what you see here. If I'm adding them together, then I have a plus sign here. If I'm subtracting the middle term, I have a subtract sign here. Let me try number 11. 9y squared plus 36y plus 36. And again, all these in this homework today will fall into this nice pattern here. So Okay. So testing it out here, does it meet the criteria to be a perfect square trinomial? First and third terms are both perfect squares. So that's the start. The square root of 9 over here, you should get a 3 on that side. The square root of 36 is a 6. In the middle, I got a positive 36, so I would have to multiply by a positive 2. 3 times 6 is 18, times 2 is 36, meets all the criteria. Put it all together. What's my answer? Well, over here with my y, I have 3y, because 3 times y. If I officially square all that, 9y squared is 3y. 3y times 3y is 9y squared. So there's that. Positive sign, so add, and then what am I adding? The square root of 36, which is 6. There would be my answer. 3y plus 6. Or, again, you can write it this way too. Doesn't matter. One or the other there. And again, you can go through and FOIL it and test it there. Not the worst idea if you're not 100% sure how this is working, but it's really just those two steps kind of over and over. I'm going to look at the backside here for a minute. So these here, we talked about remember we talked about 3 different ways of seeing this. This was 2 of them. The third one we talked about was this one here, this a squared minus b squared equals a plus b, a minus b. And what happened when we did these earlier, if you remember, flipping on back here. Like these right here, like 26. So again, we go through and FOIL, there's my e squared plus 14e minus 14e. The e's just cancel out. 14e minus 14e is no e. Negative 14 times positive 14, negative 196. But every single one of these, if you remember here, the middle just canceled itself out because this one here, I'm adding a negative 7a, I'm adding a positive 7a. This one here, I'm adding 0.5h, I'm adding negative 0.5h. Every single time they would cancel. It wasn't a trinomial, it just came out as a binomial because the middle terms would always add up to 0. And it's always going to be that way here. We went through that, this deal right here. Where again, it's just going to turn out to a plus b minus b. So we've seen this before. And this is it. So 21. Did I forget it? Yeah, just tell her I'll send it in just a second. Or just tell her Sam and Faith are hot lunch. They're all here. I apologize. So let's do this one here. Yep, 2 hot, Sam and Faith. Okay. So for these, first off, you need to pay attention here. It must be of this form here. A squared minus b squared. And once again, we can go through and just take square roots of all these. The first, for this to work here, the first and second terms need to be perfect squares. If they aren't, well then this format won't work for us. But again, the whole point of this exercise is for you to get used to these types of problems, so they will be in this format today. But there's only going to be 2 terms in here. And the first and the second terms have to be thing. So basically if I say what's the square root of 1, over here I'd get 1. And then if I said the square root of 36, I would get a 6. Or if I said 1p, then it would just be p over here. So this does meet the format, a squared minus b squared, p squared minus 36. They're both perfect squares, so what's my format? They're gonna be the exact same values. So I'll have a p, but the difference will be one will be an add, one will be a subtract of the exact same number. And in this case, it'll be 6, because a positive 6 times a negative 6 gives me negative 36. So put it all together, there's my p squared minus 6p plus 6p. They cancel out. 6 times negative 6. There it is there. What if I gave you v minus 25? V squared minus 25. What would that one turn into? I may have to just finish the last of this tomorrow. I gotta go through this last part. So the homework, just do up through 24, right here. Tomorrow we'll finish this. We can do it in class or whatever, this last part. I'll give you some time then. But for today, just for tomorrow, just get through, and then I'll go through this tomorrow. So again, v on both sides, and then plus and minus, plus 5, minus 5. Last one, then we gotta go. I'm gonna go through it. 23. So this time, 16n to the 4th minus 81p squared. Does it meet the criteria, yes or no? So over here, if I said, what's the square root of 16n to the 4th? What's the square root of 16? 4. And what's the square root of n to the 4th? N squared. And on the other side, what's the square root of 81? 9. And what's the square root of p squared? P. And there's my answer right there. Now it's just a matter of one of them's always going to be plus. One of them's always going to be minus. They'll be the exact same thing. Again, this one was a little goofier because they put n to the 4th and threw an extra couple variables at us, but still the same process repeated. We're still trying to figure out square roots of stuff, square roots, and again, just being cognizant of this rule and what it looks like when we use it. It's this binomial, this perfect square binomial scenario here. Okay, so again, if you can get through 24, that's great. We'll check those. We got to check 511 tomorrow. I will pick up and we'll walk through this last part here, how this works, and then God willing, we can get through 513 tomorrow too. So it'll be an action-packed day, I suppose.